All right, this is going to be case 5, so slightly different workflow this time. This is going to be the cases where the patient has lots of metal in the mouth, thus generating lots of scatter. And so as you can see, this patient has crowns on most of the teeth. If we were to look at just a standard cone beam of this patient, it would be very, very unclear. It would obscure most of the teeth on here, so you wouldn't have any accurate stitching points. So just by way of a reminder, the protocol when patients have that kind of a mouth with metal and zirconia and amalgams everywhere is that we need to scan them wearing a scan appliance. Now the cheap and easy way to do that is to take a PVS impression inside of a plastic tray. You can pull the impression out. Very important that you not have any show through of the tray where the teeth have protruded through. And if all looks good with your impression, then you would press on some radiographic markers onto that impression, put it back in the patient's mouth, and then scan them in the cone beam wearing that impression. And then you would also come back, remove the impression, and then set just the impression with the radiographic markers up there and cone beam scan that by itself. So 2 cone beam scans are involved in this case. So what I've done is I've opened up the patient scan. So as you can see, this is the patient wearing the impression tray. Obviously the PVS is radiopaque, so it obscures a lot of the detail. That's okay because we're going to be using this as a scan appliance. So again, we would come up to File, Import DICOMs because we have 2 DICOMs in this case. This is going to be a scan appliance. And we'll go down to Case 5 DICOM Scan Appliance Impression. Click OK. So we'll open this up. Field of view is already limited in this case, but if it wasn't, you could just use the sliders to limit that. Now, if you've got a computer that's a little bit slower, you're going to think maybe nothing is happening right now. Don't get button happy and just start clicking everywhere. This is pretty taxing on the computer, so it may take a minute to load this. Once you do, this is what is going to come up. This is the scan appliance window. And as you can see here, the software does its best to lower the density down to the point where really everything disappears except for the radiographic markers. Now, clearly, metal is so radiopaque that it can't get rid of the metal, but what it does do is just make these radiographic markers be very distinct out in space away from the teeth. Okay? The scan on the right, this is the cone beam scan of just the impression with the radiographic markers on it. And as you can see, since those are more uniform in density, the software is able to lower the density enough automatically to where only the radiographic markers show up. Bottom left-hand window, this is going to be the 3D rendering of that scan appliance, and so this should show up and appear just like the impression. So it should look analogous to if you were holding the impression in your hand. And then finally, this is the stitch window, and so this is where the software is making an attempt to stitch these two together. And what I find is that when you use these little small radiographic markers, the software generally is able to do this automatically. So if I zoom in right here, you can see these red and white dots overlaying one another. That's because the software is analyzing these dots and it's able to mesh those up to where they match. So everything is stitched automatically in the case that I'm working on here. If for whatever reason it was not, then you would do it just like you would stitch a normal case. You would push your shift button, you would come and drop a point here, and come and find that same one over here, shift, drop a point. But again, I don't find that to be necessary hardly ever when this scanning protocol is followed. So I'm just going to click OK. When I click OK, what the software does is it turns that 3D rendering into an STL of the impression. And as you can see, that impression is stitched in place. Now, that's obviously not very useful to us because we need an STL model to build a guide on. So how do we address that? First of all, I'm going to turn off in the surfaces panel. I'm going to uncheck visible here on the CT surface. And as you can see again here, this is the STL of just the impression. Now, if we wanted to digitally pour this and invert it, then we're going to go to the model manipulation panel. So go to Panels, Model Manipulation. And you may not have noticed, but down here at the bottom, there's a function called Model Reversal. And so this is what we're going to use anytime we want to invert an impression. So suppose we had a denture impression that we scanned and we wanted to create a tissue model, or we wanted to invert the inside of a scan appliance, or in this case, an impression. So what I'm going to do is push, make sure first of all that the right model is selected up here. That's the green one. Click Draw Limiting Curve. That is going to turn on the button, but it's going to be just like when you draw a guide. You can spin this around and nothing happens until you push the Shift key. So first of all, orientation is important on this. If I was to orient, let's say right here, the software is going to pour this impression straight into the page, and I would end up cutting off all of these parts of the teeth. So I want to orient this to a degree where I can see into the impression everywhere. Now I'm not worried about like that little undercut. That won't affect things. But again, you do want to orient this where you can see most of the teeth inside the impression. So once I do that, I push Shift. The mouse will turn into a crosshair, and now I can click the left mouse button, holding it down, and begin drawing the perimeter of where I want to pour this model to. Alright, so I'm going to come up and around, and I give a wide land area. I don't want to chop off the sides of any teeth by cutting it too close, like right here. Once I've done that, Edit Curve. Edit Curve will bring up the nodes where you can fine tune the positioning of this, and once you're happy with that, you can click OK, or I'm sorry, Create Inverted Model, and the software is now going to create an inverted model of this impression. So as you can see here, the model has been poured. It's now a second STL surface, and if we wanted to view that, we would go to our Surfaces panel where we can list the STL surfaces. And now let's uncheck Visible on the impression, and as you can see, we now have this model. And the beauty of this technique is that yes, you do give up some time and energy on the front end by having to follow this different scanning protocol. But the nice thing is you gain some of that back in the software side, because now you're not having to really do any stitching. By virtue of those scan appliance markers, it's doing the stitching on its own. So I'm going to come up here and make this a little brighter color just so we can see things better. Let's make that yellow. And let's look at our stitch. So first of all, I'm going to make this panoramic curve follow the maxilla a little better. There we go. And now let's analyze our stitch in the two windows I always recommend. That is the cross-sectional and in the axial view. So again, very tough sometimes to pick out stitching points when you've got this scattered from the metal, but do you see how this is lined up perfectly inside of that impression? And now if we look at it this way, we can actually make out where is the porcelain, where is the metal coping, whereas if you'd tried to pick those as stitching points, it just would have never happened. There's almost no virgin teeth in this patient's mouth to really analyze to see how good of a job it did. But as you can see, this looks very accurate. So we're going to go with this stitch. We can also look in the axial window, and I can turn the projections off with this rainbow button and maximize this and look at it in more detail. So that looks great, and now we're ready to plan the implant. So same workflow as always from here. I'm going to always start out by planning a tooth. And so this is going to be tooth number 5. I'll drop that into the 3D rendering. Use your rotation rings to position this. Now, one of the things I'm seeing here is, do you notice that I can't grab, I need to rotate this tooth this way, but it's somewhat embedded inside of these models and I can't see it to grab it. If you ever run into that, go up and select the model in your Surfaces panel and then just drag the transparency over. Get it about halfway over to where you can see into the model more, and that's going to allow you to now see your rotation ring. That can also be useful when doing a full arch case and you're trying to see implants or abutments or guide tubes through the denture scan appliance, so just a useful function. So just by way of review, if I grab just on the red of the tooth, I can bodily move it. If I grab any of the rotation rings, it's going to spin that tooth in whatever plane I'm grabbing in. So that looks pretty good. Maybe needs to come coronal just slightly. Grab the red of the tooth and drag that up. And then let's look at it from this direction. So that looks great. Once I'm happy with it, I right click the tooth and lock it. And if you wanted, you could now drag your translucency back down. Once you have that, you're ready to plan an implant. So plus implant. I'm going to go with a Biomax 3.5 by 11 as a starter. In the maxilla, I always do my abutment, so I go to the abutment tab, custom abutment, 20 millimeters long. And again, that's just for visualization of where a screw hole would end up. So I drop the implant into the pan view. I'm going to just very roughly parallel it in the pan view, but this is not the most useful view for doing much of your positioning. So once I get it just approximated, I'm going to switch over now to the tangential slice, and I'll do most of my positioning from there. By scrolling, I can spin the implant on its axis, and now I see from cross-sectional view this needs to come way over here. Some kind of crappy bone up here at the crest that you would have to take into account. Are you going to place this implant deeper? Are you going to graft that? So just something to be aware of. And here I'm obviously close to that distal root, so I need to bring that over bodily. And let's look at our positioning now. I can spin this in every dimension. I'm avoiding this root, I'm avoiding this root. Somewhat close, but that's about as good as I can get this. And if I look at this in the 3D view, I can see where that implant is going to emerge, and I can definitely restore that. That's not going to be a problem. So at this point, I'm ready to plan the guide. To do that, I turn off the teeth. So this button right here that doesn't have the plus sign, that just turns the visibility on and off. Now I need to turn on the guide tube, because if I just make a guide from here, it will be nothing more than a mouth guard because there's no guide tube on to incorporate. That's done in your implant list, and it's this checkbox right here. And as you can see, I've got the Blue Sky Bio direct cut drills chosen as the drilling method right now. This would probably be a great case for that because it's relatively narrow mesial distal space. Just from my experience, the fully guided kit, that's the one time it may struggle because it does have that large built-in key on it. It can sometimes struggle to get in between teeth. And so let's go with the direct cut drills here. This will work great. Now that the guide tube's on, I will lock the implants so that nothing gets knocked out of position here when I grab it. And let's go to the guide panel. Make sure that your model is selected that you want to build the guide on. So right now you notice that all of my buttons are grayed out. That's because I'm trying to build this on a model that's not even visible on the screen. So if you've got multiple STLs, you're going to have to choose from this drop-down menu which one you're working on. We want to check all three of these built-in drill stops if you're using the direct cut drills. I'm going to choose high for quality, maxilla, and now draw curve. Hold down your shift button and then left click and begin drawing. Whenever you run out of space and need to reorient, let go of shift, and then just continue on. I'll come up and over, reorient, continue on. Push shift, continue on, until we get back to where we started, and then I can push edit curve. Now the edit curve button is going to bring up the nodes where we can fine-tune the positioning. That looks good, and now we can create the guide. So create surgical guide. I'm going to tell it the handpiece that I'm using, which in this case is the X cube, and save, and now the software will make the guide. And there's the resulting surgical guide. If you wanted to put any text on it, you could do that here. And the only thing left would be to run the drill report, which you could print off and have available to you during the surgery. I like to print these and just tape them up behind the patient. So I could do a PDF of that, add any notes that you would want right here. You know, bone is poor on crest, buckle, whatever. You get the point. Just do that, and then you can maximize this, and now you have all the information that you need. You could use this at a glance to not have to navigate through your CT scan during the surgery. Okay, that completes case number 5.